So this is the PhET simulation on friction for your edge elastic. This is the first video, so this is only going to be working on that first set of questions. So going to friction, first make a prediction. How do you feel that friction is going to affect motion? You can pause the video while you make your prediction on how increasing the amount of friction will affect velocity. So if you have made your prediction, the next set of questions is to change the friction slider to none. Notice that I've all the other boxes checked. So add the friction slider to none and notice how the surface has changed. What does the surface look like? You can now change the friction to lots, but when it's on none, you can observe what the surface looks like and now make a inference on what type of surface would have the least amount of friction out of those options. So you can pause me again to make that prediction or make that inference. So the first part, the third question is asking you to apply force until the speed reaches maximum speed. And notice that with the friction set to none, nothing is slowing this box down. It is balanced at 40 meters per second. Now we're going to apply a force of friction and increase this force. So now that you have friction, it begins to slow down. The more friction that I add, the larger the friction force, and the faster that's slowing down. Notice that the rougher the surface, the larger the force of friction. So now we have understood one way that friction can be affected. We're now going to test how different masses are affecting friction. So we're going to be applying 500 newtons of force. And right now, just record the size of the friction force and the sum of the forces. So you can use the drag and drop to drag 350 for the sum of the forces and 150 for the friction force. Going to continue with the other objects. So once again, you can pause the video if you need to record the friction force and the sum of the forces. This is going in order of smallest mass to largest mass. So that way you can make some observations about the pattern that's occurring to the size of the friction force as mass is increasing. So now moving on to 80 kilometers. So once again, you can pause to record these numbers. And now at 100 kilometers. Notice that we have finally reached a balanced force. The friction force is too strong with this size of mass to overcome 500 newtons of applied force. So the sum is 0 and the friction force is 500. Friction can technically never be larger than the applied force, so it's always going to show up as a balanced force because friction is never going to cause it to move backwards. So it may seem surprising, but even if I do a larger fridge, the sum of the forces and the friction force are still the same. So once the friction force is larger than the possible applied force, then it is going to always be the same as a balanced force. The last thing is trying to find out the mass of this mystery object. So the way that we can do that is we can apply 500 newtons and we can observe how its friction force is 188, so we can make an inference on the mass based on which known mass it matches up with. So if we know what mass it matches up with, we can find the mass of the mystery object. So this was it for part 1, seeing how the two things that are affecting the size of the friction force is the surface. So for instance, the size of the friction force here is only 94. The size of the friction force is being affected by the surface and then also by the mass of the object. So that should take you all through part 1. and you can watch the second video of the simulation.